So the perfect square. This is an example of a perfect square. S plus 2 squared is an example of a perfect square. S plus 3 all squared is an example of a perfect square. So what I want us to do is to expand out S plus 3 all squared, this perfect square, and see what it looks like multiplied out. So what I want you to do is to work out what this is. S plus 3 squared is S plus 3 times S plus 3. So what does that come out to be? S squared plus 6x plus 9. What about the next one? S plus 4 squared. Expand that out, write down the answer. See if you can almost do it in your head. What would the answer be? S squared plus 8s plus 16. What about S plus 5? Right. There's a pattern. What about S plus A? Okay. Whatever this number is, here, I times it by 2 to get this one, and I square it to get this one, and that works every time. If I see something like this, I know that's a perfect square, and I can write it like that. So if I see this and I recognize it, I can write it down as a perfect square. These are all examples of the perfect square. Is this an example of a perfect square? Why? Right, how did you know it was S plus 6? How did you get the 6? After 12, yeah. Good. If you half the number, the coefficient of S, and square it and get the number at the end, then it's a perfect square. So that's an example of a perfect square, and it's S plus 6 all squared. Yeah, a perfect square. So that's what a perfect square is. It's an expression that can be written like this, and that comes in handy when we try and solve quadratics. For example, solve that. I could use the quadratic formula, but I recognise this as a perfect square, so I can rewrite the left-hand side. How can I rewrite the left-hand side? We've just done it already, can't I? What can I now do to try and solve it? Well, yeah, but what's the process? The left-hand side equals 0, so can I square root the left-hand side? What's the square root of that bracket? S plus 6. What's the square root of 0? Right. So what is S? Okay, S equals minus 6, and I've solved it. By recognising that this is a perfect square, I can solve it. Okay, S equals minus 6. There's only one solution. Generally there's two, but for this example there's just one solution. Minus 6 works for this case. If S equals minus 6, in this expression at the top in blue, that will work. It'll equal 0. How about something like that, look? S squared plus 12x plus 36 equals 10. Is the left-hand side a perfect square? Right. So how can I rewrite it? I can rewrite it as s plus 6, s plus 6, all squared equals 10. Now I can use the same method. S plus 6 square rooting equals plus or minus the square root of 10, because if I square root 10, the answer could be positive or negative. Plus or minus the square root of 10. And now S equals plus or minus the square root of 10 minus 6. And that's my solution. Let's look at this one. Is the left-hand side a perfect square? Okay. What does this number need to be to make it a perfect square? Right. So if I added 25 to both, I added 13 to both sides, 13 to both sides of that, I'd have a perfect square, would I not? So if I say s squared plus 10s plus 25 equals 13, then I'd have a perfect square. So I can make the left-hand side equal to a perfect square. So I can say that s plus 5 all squared equals 13. Now I can go ahead and solve it, square root both sides. S plus 5 equals plus or minus the square root of 13, and then carry on, and there's my solution. What about that? What's different about this? I've got 3s squared. That doesn't help, okay? All the ones we've seen so far is just s squared on its own. So what can I do? If I divide 3 by 3, I'll have s squared on its own. So if I divide by 3, I get this. S squared plus 4s plus 5 over 3 is 0. So now I can say this is s squared plus 4s plus 8, that's the perfect square, but I've got 5/3, so what do I need to add to the 5/3 to get 8, which is 24 over 3? I need to add 19/3, don't I? Oh, what am I doing? T squared's 4, thank you, yeah. Which is 12, so what do I add to 5 to get 12? 7, so that's equals 7/3, adding 7/3 to both sides. So by way of explanation, what I've done is I've added 7/3 to both sides because I want this to be 4. And 5 plus 7 is 12, 12 over 3 is 4. So in other words, we add whatever we need to add to make this a perfect square, i.e. 4. But remember to add it to both sides. So now I can say that this equals s plus 2 all squared equals 7 over 3. And then I can solve it.